Okay, good morning, everyone. Myself, Aishwarya Lakshmi S. from Physics Model 1. Um, Today, I'm going to take a seminar on a topic, and actually, I'm a little bit sad because the star of my topic is absent today. It is missing or hiding behind the clouds. I hope you all understood from the presentation that it is about the sun of which I am talking about. So, we all know that the sun is a star. By size and number, it ranks in the top 10% of stars in the galaxy. In our solar system, it's clearly the dominant object, brighter, massive, influential than anything else. But what is the sun? The sun, we all know, is a big hot ball of mostly hydrogen gas. It is 1.4 million kilometers across, more than 100 times the Earth's diameter, and big enough that a million Earths could fit inside it. And it's massive, really massive, about 300,000 times more massive than the Earth. So, but if we want to truly understand the sun, we have to look into its heart. The gases present in the sun is actually in the form of plasma. Plasma is a state of matter similar to gas, but with most of the particles ionized. Now, at the very core of the sun, conditions are hellish. The pressure is crushing 260 billion times the Earth's atmospheric pressure, and it has a searing 15 million degrees Celsius. Under those conditions, hydrogen is completely ionized in the form of plasma. Here, the protons are squeezed together so hard that they fuse together. Through a complicated series of steps, the hydrogen atoms fuse together to form the heavier element helium. This process is known as proton-proton chain reaction and emits an enormous amount of energy. The energy released during 1 second of solar fusion is far greater than that released in the explosion of hundreds of thousands of hydrogen bombs. And that's why the sun is so bright that you can't even look at it. Even from this distance, its heat can be felt on your skin when you stand outside. The energy released during fusion heats the gas above the core, but not quite enough to fuse hydrogen into helium. Further, from the sun's center, the gas becomes less dense, and at some point, the heat pouring up from below makes the gas buoyant. It rises in the same way a hot air balloon on Earth rises. This process is called convection. Huge columns of rising hot gas stretch hundreds of thousands of kilometers high, bringing the sun's internal heat to the surface. The gas then cools and sinks back down into the interior. Now, above the convecting layer, there is a much thinner, cooler layer very near the sun's surface called the photosphere, or literally the sphere of light. This is where the density of the material inside the sun gets thin enough that it becomes transparent. Light can shine through it, and at this point, the energy from inside the sun is free to travel into space. It is this light that we see when we look at the sun. We all know that the sun is a gas and doesn't have a solid surface. But the gas in the photosphere thins so rapidly compared to the sun's huge size that you can think of it as a sun's surface. And there is one final layer above that, the ethereally thin corona, not the coronavirus, sort of like sun's atmosphere. It is less than 1% as dense as the photosphere, but actually much hotter. Temperature there can reach over a million degrees. However, it is so thinly dispersed that it can be only seen during a total solar eclipse or using special telescopes. The corona extends to millions of kilometers and actually it doesn't end. The corona merges into what we call a solar wind. The solar wind is a stream of extremely hot charged particles that are thrown out from the upper atmosphere of the sun. This means that every 150 million years, the sun loses a mass equal to that of Earth. However, even at this rate of loss, the sun has only lost about 0.01% of its total mass from solar wind. Hot plasma moves inside the sun, creating magnetic fields, which in turn can create sunspots, solar flares, and coronal mass ejection. Let us look what are these terms. Sunspots. A sunspot is just what it sounds like. A dark spot on the sun. You can see in the presentation. It is just like pimples on your face or dark spots on your face. It forms when intense magnetic activity in the convective zone ruptures a thermal column. At the top of the ruptured column, temperature is temporarily decreased because hot gases are not reaching it. Next is solar prominence. They are bright loops of solar matter. They can burst far into the coronal layer of the sun, expanding hundreds of kilometers. Their curved and twisted features can reach hundreds of thousands of kilometers in height and width and last anywhere from a few days to a few months. Solar prominences are cooler than the corona and they appear as darker strands against the sun. For this reasons, they are also known as filaments. Next is solar flare. The process of creating sunspots opens a connection between the corona and the sun's interior. Solar matter surges out of this opening in formation called solar flares. These explosions are massive. It releases about a sixth of the total energy the sun releases in 1 second. Solar prominences and solar flares contribute to space weather, which can cause disturbances to Earth's atmosphere and magnetic field, as well as disrupt satellite and telecommunication systems. Our next term is coronal mass ejection or CME in short. CME are another type of solar activity caused by the constant movement and disturbance within the sun's magnetic field. They typically form near the active region of sunspots. The cause of CMEs are still being studied, and it is hypothesized that disruptions in either the photosphere or corona lead these violent solar explosions. The above said events generate auroras on Earth, cause power blackouts, and it can even damage satellite. During coronal mass ejection, the sun bursts out a huge bubble of electrified gas that can travel through the space at high speeds. When a solar storm comes towards the Earth, some of the energy and small particles travel down the magnetic field lines at the north and south poles into Earth's atmosphere. There, the particles interact with gases in our atmosphere, resulting in beautiful displays of light in the sky called auroras. Oxygen gives off green and red light, while nitrogen glows blue and purple. In the year 1989, Quebec, a city, suffered a massive power outage from a solar storm. The very first such storm ever detected was in 1859, and it was also the most powerful ever seen. If an event like that were to happen today, it could cause worldwide blackouts and would be very damaging. Satellites would be fried, and we depend on these satellites for our modern civilizations. In fact, in the year 2012, a huge storm, probably equal of the 1859 event, blasted away from the sun, but in another direction, missing the earth. This is why studying the sun is so important to us. Understanding it is critical to our future. We need to respect that sun, to which life in earth would have been impossible. And that's all about my topic. I hope you all understood about the sun, and we are really missing the star of the topic, sun, today, because today is a rainy day. And here we come to the end of the seminar, and I thank our head of the department, Dr. George James, sir, for giving this wonderful opportunity to present my knowledge before you. And if you have gained any new information from this seminar, that would be my success and that would be my happiness. Thank you.
Thank you, Aishwarya Lakshmi.